If I give you a set of values of x and y in tabulated form, and I tell you, hey, these belong to a polynomial. Now I have not given you an equation for the polynomial. By just examining these values, would you be able to find out the degree of the polynomial and also the leading coefficient? This is a question that we'll try to answer in this lesson using a concept known as finite differences. So let's get started. Let us see an example of a polynomial y equals to x squared plus 2x plus 1. For this polynomial, we have been given a table with the x and y values. Now the first thing that needs to be taken into account is that these x values should be equally spaced. So if we examine these x value, so each interval is of a duration of 1 unit. So if we see -1 minus -2, that comes out to be equal to 1. Then 0 minus -1 comes out to be 1 again. And similarly, 1 minus 0 is 1, and 2 minus 1 is 1, 3 minus 2, and 4 minus 3. So all of these are 1. So this is the first very important thing to check out. Once you have checked this, then we look at the values of y. So the values of y can come from this equation, y equals to x squared plus 2x plus 1. So if you substitute the corresponding values of x in this equation, you'll be able to get the value of y. So now we have to find out something which is known as the first difference. Now what is a first difference? Basically, the first time we are going to subtract consecutive values of y from each other, what we get is the first difference. So if we subtract 1 from 0, that is, if we say 0 minus 1, what we get is -1. Then if we subtract 0 from 1, that is 1 minus 0, this comes out to be 1. 4 minus 1, this comes out to be 3. 9 minus 4 comes out to be 5. 16 minus 9 comes out to be 7. And 25 minus 16, this comes out to be equal to 9. So these values, the first time we subtract consecutive values of y from each other, what we get is the first difference. So these values, they are the first difference, -1, 1, 3, 5, 7 and 9. Now if we look at these first difference value, we find that these are not same. Okay, so they are not equal to one another. So if they are not equal to one another, we have to move to the next step, and that is finding the second difference. Okay, so how do we find the second difference? Now instead of y values, we are going to consider these first difference values. Okay, so this time we'll find the second difference from the values of first difference. So this time we'll do 1 minus -1, and this gives you a value equal to 2. Okay, the next thing is 3 minus 1, which is again coming out to be 2. Then 5 minus 3, this comes out to be 2 again. Then 7 minus 5, this comes out to be 2. And 9 minus 7, this again comes out to be 2. Now here we see that all values of second difference come out to be 2. So they all are same. So all these values are same or they are constant. So when we find a difference in which all values comes out to be the same, then we are going to stop the process. So what we conclude here is that this second difference, this is constant. Okay. So this value is a constant value. Okay. Now let's see this in the form of slides. So this is the first difference that we calculated. This is the second difference which we calculated, and it came out to be equal to 2, which is a constant value. So this is the observation that we have here. We found that the second difference is constant. If you look at the degree of this polynomial, then this is the term which has the highest degree, x squared. So what is the degree of the polynomial here? It is 2. So since the degree of the polynomial is 2, the second difference is going to be constant. This is a second degree polynomial and its second difference is constant. Another thing to be noted is that for this particular polynomial, what is the value of the leading coefficient? So the term with the highest degree is x to the power of 2. So what is the leading coefficient? It is the constant term in front of x squared. So what is the leading coefficient? It is 1. Okay. So what is the sign of the leading coefficient? Leading coefficient is positive 1. The sign of the leading coefficient is positive or you can say plus sign. So we can also see that the second difference which we get also has a positive sign in front of it. So it is plus 2. Okay. So both the second difference as well as the leading coefficient have the same sign. So this is what we concluded from here. Okay, or we can say it's just an observation that we have taken. Maybe we come to a conclusion later. So now let's look at other examples.